Hello guys, my name is Dylan. My YouTube channel is DRG Bros. And today we are going to be doing Exponents and Logarithms 1. So as usual, we're going to start with topic 1. And we're going to start with what's called a rational expression. So it's going to be 12x minus 7 over 6x squared minus 7x plus 2 dx. Okay. So this is a rational expression right here. Okay? And so by doing some simple polynomials, we can figure out that, so the top will stay the same, 12x minus 7, but the bottom is going to be 2x minus 1 and 3x minus 2. Now let me just review really quick what is a polynomial. So a polynomial has like x squared, x cubed, x to the fourth. But what is not a polynomial is this. Let's say x to the 1/2 plus x to the -2. This is not a polynomial because you can't have fractions. Okay. So our next step would be to solve the partial fraction. But I'm just going to tell you guys the answer. So it's going to be 2 over 2x minus 1 and plus 3x minus 2. So we could split this into two parts. So we have 2 over 2x minus 1 dx, and then plus the integral of 3 over 3x minus 2. And this also has a dx. And then what we can do is we can do this equals 2 1 over 2x minus 1 dx plus 3 1 over 3x minus 2 dx. And so this is when we take in our u substitutions. So we're going to have to do 2 u substitutions. So we're going to let u1 be equal to 2x minus 1. And then u2 equals 3x minus 2. So we're going to have a differential du over dx equals 2 multiplied by dx. And then we have du equals 2 dx. 2 . 2 2 over 2. And these cancel out, so we're left with du over 2 equals dx. Now for the other one. We're going to do du over dx equals 3 dx cross out. Now du over 3 equals 3 dx over 3. Cancel out. Du equals dx 3. Okay? So now that we've done this, we can do this. So it's 2 1 over u du over 2 plus 3 1 over 1 over u1 and 1 over u2. If you remember that. 1 over u2 du over 3. Okay? And then what we can do is we can make fractions. So we're gonna carry this over, and we're gonna have 2 over 2, 1 over u du plus 3 over 3 1 over u2 du, and then these will cancel out. And then 1 over u du is the same as the natural law of u plus, this is u1, natural law of u2. And then this equals the natural law of 2x minus 1 plus the natural law of 3x minus 2. Okay, so this is topic 1, our review. Now let's move on to topic 2, which is going to be exponents. So, most people have seen squares and cubes. So, this would be 2 to the third. 2 cubed. So, what would that be? This would be the same as 2 times 2 times 2. So, in this case, you want to make 3 copies of 2 and then multiply them. So what about x cubed? Now x cubed would be the exact same thing as x times x times x. And then what about x to the third times x to the fourth? Well, this equals x times x times x, and then times x times x times x times x, which is the exact same thing of x to the 7th. So what about now xm plus x to the n? And so you'd probably be thinking that we need to figure out what m and n are. But we don't need to, because this equals xn plus n. And we always want this to work. And this is really important and key. So what if we had x to the n plus x to 0? What would it equal? Well, it would be equal to x to the n because it's 0 and it has because n plus 0 equals n. So what if we do this and we multiply each side by each other? So xn plus x0 equals xn. And so we're going to multiply this by x to the n, and we're going to multiply this by x to the n. So these are going to cancel out. And then what is xn divided by xn? It's 1. So what this means is that x to 0 equals 1. Now what about xn times x of negative n? Now this is going to equal x to 0. And if we multiply this by each side, so we're going to have xn times x to negative n over xn. These are going to cross out. And this is going to equal x0 over xn. And so we figured out that x0 equals always 1. So what this means is that x of negative n equals 1 over x to the n. Now, what if we do one more thing? So we have a to the negative 3 and then b to the 4th over c to the 5th and then d to the negative 7th. What we can do is we can move this a down here to make it a positive. So this now equals a3 c5 and then it's b4 d7. And then this equals b4 d7 over a3c5. Okay? So that was topic 2, exponents. And now we're going to move on to the final topic of logarithms. So let's start out by writing a logarithm. So let's get a new sheet of paper. And our first logarithm It's going to be the logarithm of 8 base. So this is called the base, and it's pronounced logarithm of whatever this is, base whatever this is. So it's, in this case, it's logarithm 8 base 2. And so this equals something that will go above the 2 that then will equal 8. So in this case, the answer is 3. Because 2 cubed, let's see, so 2 times 2 is 4, 4 times 2 is 8. So that means 3 is correct. Okay, let's try another one. They're going to start out easy and they're going to get harder until the end. So we're going to do the logarithm of 9 base 3. Now, by looking at this, you'd assume that the answer would be 3, because 3 times 3 is 9. But actually, if you said 3, then 3 times 3 would be 9, 9 times 3 would be 27. Because this goes above the 3, and then that has to equal 9. So the actual answer would be 2. Because 3 times 3 is 9. Now what if we did the logarithm of 27 base 3? Now we already kind of solved this one. It would be 3, because 3 cubed would be 27. Due to 3 times 3 is 9, 9 times 3 is 27. Okay. So now let's do the logarithm of 100 base 10. Now what does this equal? If you said 10, then you're somewhere in the 10 billions or somewhere like that. But it's not even, because if it was 10, then 10 times 10 would be 100. 100 times 10 would be 1,000, and so on until you get like really high up and you did like 100,000 times 10, and it just keeps going higher and higher. But think of this. So we're using exponents. So how many times do you need to multiply 10 to get 100? 2. Because 10 times 10 is 100. So the answer would be 2. That would become, because 10 squared would be 100, and that's correct. Now, what if we did the logarithm of 1,000 base 10? This would equal 3. Because 100 times 10 equals 1,000. And since we already know that 2 times 10, or 10 squared equals 100, 10 cubed must equal 1,000. So now they're going to start getting a little bit trickier. This is going to be the last easy one that we do. So the logarithm of 25 base 5. Now this one looks like it's 5, but that wouldn't work. So it would so it's lower than 5. Now 5 times 5 is 25. And the only way you can get 2 copies of 5 is if you use 2. Because 5 squared, that's 5, and then times 5, which equals 25, meaning that that's correct. Okay. What if we do the logarithm of 10 base, and then that 10, logarithm 10. When there's nothing there, it's commonly a 10. So 10 base 10. Well, this is pretty easy too. But what times 10 equals 10? 1. So 10 times 1 is 10. And there's only one copy of 10. Now what if we make it a little bit more complicated? What if we do the logarithm of 1 base, and there would be a 0 here, but since it's traditionally a 10. So 1 and then 10. Okay. So this one is pretty confusing unless you think about it. And you also have to look back into the previous topic. Because in topic 2, we have a part that says x to the 0 always equals 1. So that means, but we don't know, x could be any number. So if in this case x is 10, and then 0, so 10 to the 0 power would be 1, because we proved that in topic 2 when we said that x to the 0 equals 1. So the answer is 0. Okay. Now this is also a pretty confusing one. So what if we do the logarithm of 1/10 base 10, because there would be a 0. So this one's also pretty confusing, but on our paper it says that x minus n equals 1 over x to n. 1 over x to the n. And then it's a negative x, it's an x and then a negative n. So it's going to be 1/10, and then it's going to be negative something. So it's actually negative 1. And then let's do one more, and this is the trickiest of them all. So let's do the logarithm of negative 10 base 10. So this one is fairly confusing unless you think about it, because what it is it's not actually something, because there's no possible way. So it is, because if we do a negative, because it can't be a positive, because 10 times 1 is 10, not negative 10. Can't be a fraction, could still be positive. Can't be a negative, because a -1, it would be a fraction, and that can't work. And so, but that means that nothing, but what else is there? There's nothing. So this is an imaginary number. Thank you guys for watching. I hope you enjoyed, and I'll see you next time.